In this lesson, you will learn about the polymerization of ethene. You will learn how to draw polyethene and the uses of this polymer. Polyethene is formed by the polymerization of ethene. Ethene is an alkene with two carbon atoms joined by a double covalent bond. Polymerization occurs when this double bond breaks at a temperature of around 200 degrees C and a very high pressure of 2000 atmospheres. When the double bond breaks, adjacent molecules link together to form very long molecules of this repeating unit. The repeating unit was known as the monomer. So for example, in polyethene, the monomer is ethene. As you can imagine, using different monomers creates different polymers, with different repeat units along the chain and therefore different properties. We also have videos explaining the polymerization of propene and chloroethene. To write an equation for the polymerization of ethene, you should first start with the reactant ethene. And to show the polymer product, we must break the double bond and extend the covalent bond outside of either side of the square bracket. This shows us that it is this unit that is repeating along the molecule's long chain. Since the number of molecules that can join together to make up the polymer can vary, we use N to represent the number of repeat units. Consequently, we must also go back to ethene and balance the equation with N number of ethene molecules going in. This type of polymer is called an addition polymer. The monomer is just repeated and only one product, the polymer itself, is formed. The number of molecules that join together can vary, anything between 2000 and even 20,000, making some very long polyethene molecules. And this long chain lengths give rise to some of its properties. There are two different forms of polyethene, low density and high density, differing in how they are manufactured and their properties. Low density polyethene is commonly used for plastic bags and similar thin sheet-like low strength products. High density polyethene, often referred to as HDPE, is stronger and has a higher boiling point. It has many uses, some of which include plastic bottles, chemical and water pipes, food storage containers, and even folding chairs and tables. Now, by the end of this video, you should be able to write equations for the formation of polyethene and give examples of some uses of this polymer.